So this is guided practice 4.2, and this is parallel lines day 2, and our objective is to find the measure of angles using the properties of pairs of angles formed by parallel lines in a transversal. We're just going to do a little bit of a review here. We're going to complete some of these following statements by choosing the correct statement to complete it. Parallel lines have the same or different slopes if plotted on the xy coordinate plane. Well, we really haven't talked about this yet, but I'm hoping that you remember from Algebra 1 that parallel lines have the same slope. Okay, we haven't done any plotting yet. We hope to do some before the end of the unit, and then you'll see a lot more information about this, but parallel lines have the same slope. Let's go on to the second question. If one parallel line is perpendicular to a transversal, then the other parallel line is sometimes, always, or never perpendicular to the same transversal. Well, let's draw a picture, and let's see if we can figure out the answer to this. So if we have a parallel line, well, we have one line, and then we have another line that is parallel to that line. I'm trying to draw these as best as I can as parallel lines. And then we have a transversal, which is perpendicular to one of these lines. Okay, I'm going to draw a transversal that's perpendicular. I'm going to indicate that with a right angle. So we'll call this T for transversal and A and B for the two parallel lines. If the transversal is perpendicular to one of the parallel lines, then is it sometimes, always, or never perpendicular to the same transversal? Is it perpendicular to the other parallel line? Let's try to reason this out. Let's number these angles just to kind of talk about them. 1, 2, 3, 4, 5, 6, 7, 8. Angle 2. Does it have a corresponding angle down here? Angle 6, right? The upper right angle here is corresponding to the upper right angle here. Why did I draw a right angle in here? Because we know that corresponding angles are congruent. Okay, well, what do we know about angle 1? Well, we know that 1 and 2 are a linear pair, and angle 2 is a right angle. So whenever you have a linear pair with one of the pair being a right angle, the other angle has to be a right angle also. And the same is true down here with angle 5. Well, we still have 3 angles left, angles 3, 4, 8, and 7. Well, I think you could see that we don't even have to use parallel properties anymore because we know 2 and 3 are linear pairs. We know that angle 2 and 3 have to be supplementary, so angle 3 has to be a right angle, and so does angle 4, and the same thing is true down here. So all these angles are right angles, and if two lines intersect and form right angles, then those two lines are perpendicular by the definition of perpendicular lines, and therefore, if one parallel line is perpendicular to a transversal, then the other parallel line is always perpendicular to the same transversal. Next question. Parallel lines eventually do or do not intersect each other if extended long enough. Well, let's remember our definition of parallel lines. I've just got handy here our definition from one of our previous lessons. Parallel lines are lines that are coplanar and do not intersect. So if the definition says they do not intersect, then they do not intersect. Let's look at the next question. If one parallel line is intersected by a transversal, then the other parallel line is always, sometimes, or never intersected by the same transversal. So let's draw a picture. Let's draw parallel lines. And now let's draw one of the parallel lines being intersected by a transversal. I think you could see that the answer is going to be always. That if one parallel line is intersected by a transversal, that transversal will always intersect the other parallel line. Okay, is there any way you think you can prove that? Not sure we have enough ability to prove that, but I think that we can imagine a transformational proof with patty paper. If you'd like to go ahead and do that patty paper proof for yourself, feel free. Let's look at number 5. Question is, two distinct parallel lines can sometimes, always, or never each go through the same point. Well, can they ever go through the same point? Well, if two parallel lines went through the same point, that would mean they intersect at that point, right? How else could they go through the same point? Do two parallel lines ever intersect? They never intersect. So the answer here is never. Two distinct parallel lines, distinct means that they're separate lines, two distinct parallel lines can never each go through the same point because they never intersect.